Today's video is going to be a little different, but we are still going to be talking about chemistry. Acid-base reactions that form gases is what we're talking about, and basically we're going to take a look at two reactions that have a product of being a gas, and that's what we're looking at here. Okay, so the very first thing we'll talk about is we have an acid, and it can be a strong acid or a weak acid, and we're going to react it with what's called a metal sulfide. Metal sulfides will produce hydrogen sulfide gas. They'll also produce a salt. Now, one of the things that we should probably define is what is a metal sulfide, and that's just going to be an ionic compound that has a metal, and it's also going to have a sulfide in it. And a couple examples here. We have sodium sulfide Na2S or magnesium sulfide MgS. Those are both metal sulfides. And the hydrogen sulfide that's going to be made as a result of acid reacting with a metal sulfide is going to be hydrogen sulfide, and that's going to smell like rotten eggs if we were to smell it. Not a very pleasant smell. Okay, so we'll give you an example here of an acid plus a metal sulfide. We have a 0.5 molar solution of hydrochloric acid being reacted with a 0.5 molar solution of sodium sulfide, and we're going to go ahead and write a complete equation, an ionic and then a net ionic off of this. So here is our complete equation. We have hydrochloric acid, we have sodium sulfide reacting. Now, one thing we need to recognize here is we have a metal and a non-metal, we have a metal and a non-metal, and we can treat this like a double replacement reaction. So that's what we're going to do. We're going to form sodium chloride in aqueous solution, and we're also going to have bubbles coming out of this, and they're going to be very stinky bubbles as the hydrogen sulfide gas there, and that's just something that we're going to kind of commit to memory as hydrogen sulfide is going to be produced. Now, when we go to ionize this reaction or dissociate this reaction, remember if we do have HCl, this is a strong acid, one of our 7 strong acids, so we are going to ionize it into the hydrogen in the chloride, and I'm not going to balance it till the end. Sodium sulfide was a solution, and it's got an alkali metal in it, so we're going to ionize that to sodium ion and the sulfide ion. Sodium chloride, because we're going to have some liquid going on the other side, it's definitely soluble, so we're going to ionize that. And because we are making H2S, that hydrogen sulfide, that is going to be our gas, and we are not going to ionize that because we don't ionize gases. And so if we want to go through and eliminate our spectator ions, we would cross out sodium here. It's a spectator ion, sodium there. Also the chloride ion and the chloride ion would be crossed out, and there we go. Net ionic equation, hydrogen plus sulfide equals hydrogen sulfide gas. Alright, the next thing we'll talk about are compounds that involve bicarbonates, also known as hydrogen carbonates, as well as carbonates themselves, and these compounds are going to react with acids. So I'll give you an example, and we know this one, sodium hydrogen carbonate. This is our baking soda, and just sodium carbonate, which is usually one of the results of when baking soda decomposes. So we're going to react both of these type of compounds with an acid, and they're going to do something very similar. Okay, so the first thing is, let's take a look here. We have a 2.5 molar of hydroiodic acid reacting with 15 mils of a sodium, potassium hydrogen carbonate or potassium bicarbonate. Complete reaction, we have Hi over here, hydrogen iodide, and then we have our potassium bicarbonate here. And again, a double replacement reaction. Potassium here is going to change places with the hydrogen there. We rewrite it over here as H2CO3, which is actually carbonic acid, but there's going to be something interesting that happens with our carbonic acid here in a little bit. And then we have Ki, which is just potassium iodide formed. So just a double replacement reaction, but there's this huge difference that's going to happen right here, and let's talk about that in the next slide. Okay, so for our complete equation, here we go again as our complete equation, and we're going to ionize everybody. So for the Hi here, it's one of the 7 strong acids, so we're going to ionize that as the hydrogen ion and the iodide ion. We have potassium bicarbonate, which has got that alkali metal in it. It said it was a solution, so we're going to ionize potassium, and we're going to ionize it into the bicarbonate ion. And here is what really happens that's interesting. This carbonic acid is very, very, very unstable, and as soon as it's made, it's going to decompose, and it's going to decompose into two products. It decomposes into water, it decomposes into carbon dioxide. So that's just something you got to know whenever you form carbonic acid. As a result, quickly decompose it into water and to CO2. And then of course our last one here is we have potassium iodide, which is soluble, so we're going to break that down into potassium and iodide. I think you could probably see where we're going with this. We're going to have some spectator ions, and so let's cross some of these spectator ions out. We have the iodide, we have the iodide, we have the potassium ion here, and we have a potassium ion there, and so we're left with a net ionic equation that looks like this. The hydrogen ion from our acid reacting with our bicarbonate ion gives us water and CO2. Let's take a look next at our metal carbonate. Now metal carbonates are just going to be just a little bit different than the bicarbonate. They don't have that hydrogen in them. So sulfuric acid solution, again a strong acid, is mixed with a sodium carbonate solution. And here is our complete equation. There's our sulfuric acid, there's our sodium carbonate, and double replacement reaction. This sodium is going to change places with the hydrogen, and then we're going to have to re-crisscross charges to write our new formula. We've got sodium sulfate being formed, and then we've got, oops, I'm sorry about that, we've got our carbonic acid being formed here. Again, it's going to do the same thing. It's going to immediately decompose. So again, here's our complete equation. Here's our carbonic acid over here. And so let's go down here and talk about why these are broken up. First off, we have our strong acid, sulfuric acid, which is going to break up into the hydrogen ion and the sulfate ion. We could break that up into HSO4 1- plus a hydrogen ion. Either way will work. We have sodium carbonate, which is an aqueous solution, so we're going to break that up because it has the sodium ion in it and the carbonate. It breaks up, I'm sorry, just because it has the sodium ion in it. Sodium sulfate, again, an alkali metal, is going to be soluble. And then there's our carbonic acid, and carbonic acid is going to break up into water and into carbon dioxide like we said before. And hopefully you can see now that we have some spectator ions. The sodium and the sulfate ions are going to be spectators. And so we're going to go over here and we're going to cross some of these out. So we cross out the sulfate, we cross out the sodium, cross out the sodium, cross out the sulfate. And so again, we get a very similar net ionic that we did with the hydrogen carbonate. And that's it for today's lesson on acids with metal sulfides and metal bicarbonates and metal carbonates. And then we'll do some practice problems on these on Monday in class. Hope you have a fantastic weekend.